Yeah, now let's discuss about formulas in physics used in schooling. These are some of the formulas which are used in schooling, school level physics problems. See, like you will be doing problems, you will be taking the help of length, distance, displacement, height, width, all that. Okay, you will be coming across mass. Most of the time, you will be coming across the physical quantity mass, and moreover, it's a fundamental quantity also. Time, oh, most probably always time. Okay, it is found in velocity, speed, acceleration. Everywhere you will find time, and you will find about area. Then, because when you want to calculate pressure, it is force per unit area. So you should know what is the actual unit of area. In the same way, if we speak about volume, quite natural volume. Simply volume, you will not know what actually its unit is. It is length into breadth into height. That means nothing but length into length into length. Therefore, it's length cube. So if it is MK system, meter cube. If it is in CGS system, centimeter cube. Now coming to acceleration. Why its unit is meter per second square? Why? Why it is? We will come to know. Same way pressure. Pressure is force per unit area. Right? Force per unit area. You should know that unit for force in SI system is Newton. Right, these things, right? For that sake I wrote few of the things here. One thing you should know that we have systems of measurement CGS, MKS and SI. As you know, first three physical quantities are fundamental quantities. They are length, mass and time. So these systems are written according to length, mass and time. So the unit for length in CGS system is centimeter. The unit for length in NK system, just under L, what is it? Meter. The unit for mass in CGS system, under mass, what do you have in CGS system? G. Therefore, it is gram. What do you have there in NK system? What is under M? It is K. Therefore, it is kilogram. And time is second and second. Now, you know all this very well. In SI system also, this remains same. Meter, kg and second. Now, what I actually want to tell you is, there is a problem. Right? Like I came across a problem in motion, lesson motion, saying that a rope can bear 450 Newton. Right? If a 50 kg mass is tied to it. Now you tell me, a rope can bear 450 Newton is given, that's all. He has not used the term called force at all in the problem. How will you come to know that it is force? That means you should know the units properly, then only you can do the problems. Right? In the same manner, the other problem also I came across, right? Like given, right, a vehicle is moving with high velocity, right, and it is having, say, 10 meter per second square of its acceleration. First of all, you should know what is acceleration, isn't it? Acceleration means what? Rate of change of velocity. That means nothing but what? Velocity by time. Simply if you say velocity by time, how will you get meter per second? That means you should need to derive them. Why? Because acceleration is a derived quantity. What actually I am doing this video is to just communicate the students that if you look at the unit, you will understand the physical quantity. And according to that, if you take down like given values, given something is given like 10 Newton, that means you will understand that it is force. Okay, given is 10 meter square is given. Okay, meter square means you should understand that there are 2 meters in that. Meter into meter, that means it is length into breadth, that means it is area. That's why it is given as meter square. So you have something like Newton and you have something like a meter square. That means force is given, area is given. Then what is alternate? What is that you are supposed to find? Pressure. Why? Because pressure only has the use of these two. Pressure is called force per unit area. So I want to communicate this one. See, like current. If you take current, it is CURRENT, current. But you know it is actually represented with I. And you know its unit is A, amperes. Right? 10 amps flowing for a period of 10 seconds is given. How will you know that given one is current? That's what I am telling you. If you know that ampere is a unit for current and second is a unit for time, then you will simply aptly find out what is charge, because Q is equal to IT. I is current and T is time. In the same manner, 90C is given in your problem. 90C. What does C mean? Coulomb. Right? Coulomb. You know, Coulomb is a unit for what? Charge. But interesting thing about charge, CHARGE. As such, there is no alphabet called Q. But still, charge is represented with Q. And its unit is another interesting thing. Its unit is Coulomb. So you should link up all this. So what I want to tell you very simple is, I want to show you now on the board. You are given say 10 meter. 10 meter is given to you, right? Say one more value is given like 10 meter per second square. Say one more is given like 10 meter square, and one more is given like 10 meter cube. Right? A few more things like 10 kg is given. Okay. So I am speaking about SI unit. In particular, I am doing a video only on SI units, because most of the time we will be doing problems on SI units only. So given for you, say like this, 10 Newton per meter square. Now you tell me, does this 10 communicate anything to you? No. The numerical value does not communicate anything to us. Nothing. Right? So as such, no use of taking numerical value into consideration. They don't communicate to you anything. Okay? What happens when you look at this one, you will come to know this may be height, or say distance, or say it may be a displacement, or say length, simply like that by looking at meter. Because just now I said no, CGS, NKS, and you should know these are written according to length, mass, time, and these are the main fundamental quantities. As I told you, I had made a video on measurement. You can refer to it. Okay. In general, there are just only seven fundamental quantities. All the other quantities are derived. So now looking at this one, meter is a unit for what? Length in MKS. So I am speaking something about meter. Meter means it is related to either it may be height or length or distance or displacement, because the unit for all this is meter. Now when I come across this one, it is meter per second square. So it is what? Related to acceleration. Now meter square very clearly tells you that it is meter into meter. This shows that it is meter into meter. That means it is length into breadth. Therefore it is area. Simple. This is meter cube. Meter cube means if it is m plus m plus m, it will be 3m sum. But when it is a multiplication only, you will get these type of things. That means what is understood now? This may be length, breadth and height. So length into breadth into height, nothing but length into length into length. Therefore length cube. Length cube means it is volume. So I understood that kg means it's a unit for mass. So something mass is given. When I look at this one, it is force for me, and when I look at this one, it is area for me. Therefore force per area means it is pressure. So see, what I want to tell you is so simple, that you can concentrate more on units. By looking at the unit, you can simply identify the physical quantity. So if you write down the physical quantity like given, then easily you will get the formula. You will come to know what you are supposed to do. Suppose, so say I have something like 100 meter is given to me, and 20 second is given. 100 meter, that will be my distance or displacement or length or height, something like that, related to length only. What else is given? 10 second, as I said, 10 second or 20 second, something I said. So second indicates that it is time. So I have something like distance and I have something related to time. Then what will be my physical quantity I am supposed to find? It will be velocity or speed. Why? Because speed means it is distance by time. Given to me is distance and time is given. Right? So in that way, it is easy for the students if you can really concentrate on the units. Okay? Right? For example, say acceleration. What is acceleration? Rate of change of velocity. That means it is velocity by time. So write, let velocity be like that. You write time aside, time. Because this is denominator, so you are writing aside. What is left over is velocity. What do you mean by velocity? It is displacement by time. Okay, now finish. Distance, displacement, length, height, width, everything means nothing but length. It is nothing but length. So it's length now, length into 1. Therefore it's length only. What do I have here? Time into time. I have time square. So what will be my unit for length in SI system? Unit for length in SI system. SI is similar to what? MKS. So it's length, mass and time. So it's meter. So this will be meter. While my time is time square. Therefore meter per second square is a unit for acceleration. This is everything, everywhere it is same. That's why I already wrote. I need not explain you each term. It is understood. See, impulse, force into time. So force unit will be Newton. Force unit is Newton. Length, distance, displacement, width, all come under one category, meter. Okay, mass means kg, time means second. If you are coming across force, it should be Newton, Newton. If you are coming across acceleration, then it should be meter per second square, something like 100 meter per second square. You need not worry about 100. That 100 does not communicate anything to you, but meter per second square communicates that it is acceleration. Okay, suppose something is like 100 meter per second, only second, it communicates that it is velocity or speed. So look at the units, try to understand the units. If you can really remember the units, then it is easy for you to solve problems. Among this, you remember relative density. Relative, when you speak about anything like that, it does not have any units because it's a ratio. So you are comparing relative density means density of the substance by density of water. As such, it is a comparison. Ratio, it is a ratio. So you will not have any units. Another term related to this one same is what? Refractive index. N is equal to C by V. Again, it's a ratio between velocity of light in vacuum by what? Velocity of light in any media. That is N is refractive index, C by V, where C is called velocity of light in vacuum and V is called velocity of light in any medium. Therefore, again it's a ratio. Since it is a ratio, you don't have any units. So it is very easy if you really concentrate on units only. Particularly I am telling you units. Something is given to you, kg. You should understand that what is given is mass. Something is given to you, meter per second square. You should understand clearly that meter per second square means given value is acceleration. Given say meter per second, you should understand meter means it's something like distance, per second means time. So it is distance by time. You should understand given value is speed or velocity. Right? In this way, we can solve problems of physics very easily if you know what actually the unit is communicating to you. The numerical value, whatever is present before the unit, does not communicate anything. It's just a numerical value. If it is 1 meter per second and 10 meter per second, it can simply communicate that 10 is a larger number compared to 1. That's all, that much only. So say 10 meter per second, I wrote it as 10 kilometer per hour. Then 10 remains same everywhere, but since kilometer per hour, it adds more value. It is considered as bigger value. That's all. Other than that, that kilometer per hour only will tell you that it is an unit for velocity or speed. In this way, it is very easy. If you are speaking about pressure, pressure is force per unit area. Force unit is Newton. Pakka, something like 450 Newton, like that it is given. You should understand that is force. Right? Meter square is given. And meter square means it is nothing but it is having 2 meters in that. Meter into meter. That means length into breadth. Right? Length into breadth means what? Area. That's why area unit always it will be meter square or centimeter square or square meter and all that. When you come across volume, meter cube. Why it will be square? Tell me. It will be cube because it's volume. Length into breadth into height. Right? Same way charge. Q is equal to IT, right? That's a formula. I is equal to Q by T. Q does not means charge, CHARG, charge does not have anything related to Q, but actually charge is represented with Q and its units is coulomb, right? In this way, if you can know these given values, then you can solve the problems easily. Thank you. Now I will explain you dimensions. How to write dimensions? Okay, right. Very good. For example, let me take acceleration only. Acceleration is what? Acceleration is rate of change of velocity. Rate of change of velocity. That is delta v by delta t, or it is nothing but v minus u by t. Okay. That means nothing but what it is, velocity into 1 by time. Why did I write 1 by time aside? I want to write the units first. Now coming to unit, velocity means what it is? Displacement by time. Into I have here something like 1 by time. What did I tell you just now? Displacement or distance or length, everything means length only. It's length by time, and time it is time square. Now dimensional formula is like this, M, L, T. Now tell me, what is my denominator? Time. Time is my denominator. Therefore I am bringing it on the top. Therefore my time will become square inverse. Square inverse it is called. Length is already on the top, so length is 1. I don't have mass related something here. Therefore mass is 0. This is the dimensional formula of acceleration. What does it mean? Now I am coming out from acceleration as a dimensional formula to the unit of acceleration. What does this indicate? I don't have anything related to mass. Okay. What else then? Length, I have something related to length. So it will be meter on the top. The time unit is second square, and this is from the down. It has come from denominator side. Therefore meter per second square or meter second inverse. This is a unit for acceleration. See, this is easy to write dimensional formulas. Now I will write dimensional formula for pressure. Most of the people feel that writing dimensional formula for units like physical quantities like pressure is difficult. As such, there is nothing like that. Pressure. So what is the formula for pressure? Force per unit area. Right. What is force? First of all, what is force? So pressure is equal to, force is what? MA. Nothing but MA. F is equal to MA. Sorry. F is equal to MA. F is equal to MA. Mass into acceleration by area. So it is nothing but what? Mass into acceleration into area is by area. So I will put area here. Now you remember area? Length into breadth. Means length into length. Means meter into meter. That is meter square. What did I tell you about acceleration? Rate of change of velocity. That means it is velocity by time. So let me write time aside, mass into, what is this one? Velocity. Velocity means what? Displacement by time. Displacement by time. So I am writing only for the sake of velocity this one. I have something time related, so let me write it as side time into 1 by m square. What is my m square? Area. Right? Now what is this one? Now I have mass. Everything is now turned into fundamental quantities. That is mass into distance or displacement is length by time into time is time square into what else is left out? Meter square, that is area. Mass, what is the unit for mass? Kg. What is the unit for length? Meter. By, what is the unit for time? Second square. Here, what is the unit for area? Meter square. So meter and this meter, 1 meter gets cancelled. What is left over to me? Kg by second square into meter. This is something for pressure. Now how to, nothing but what we call this one? Pascal also. Pressure unit is Pascal. Okay, or else it is Newton per, it's here. Pressure is force by area, nothing but Newton by meter square. But I am doing all this for the sake of first dimensional formula. Now tell me, kg mass, so it's on the top 1. Second, it is somewhere down, so let me bring it on the top. Sorry, so it is -2 square inverse. And what else is meter is also on the top. I am bringing it on the top, so this becomes the dimensional formula of pressure.